Students, this is the last part of periodic table. We're going to talk about elements in a period. Okay, all this time we've been focusing on groups, so let's just focus on periods really quick. So pulling up the periodic table, we have 7 periods. Okay guys, and periods go horizontally like this: 4, 5, 6, 7. Okay, we have 7 periods. Now if we look at sodium and magnesium, okay, I'll just write them down: sodium and magnesium, they are both in the same period. Sodium has 11 electrons, magnesium has 12 electrons. So it is safe to say, when going across a period from the left to the right hand side, the next element has 1 electron more than the previous element, or you can say the proton number increases by 1 as you go from left to right, because number of electrons equals number of protons, right guys? Right. Now there are some properties that we need to know about periods. Now we're going to focus specifically on period 3. Okay, for some reason Lembaga Peperiksaan likes to talk about period 3. So let's go through some of the properties. Okay guys, the biggest property you need to worry about, guys, is atomic radius. Okay, I remember this very well. It used to come out on my SPM. Atomic radius for all the groups increases, right guys, because number of shells filled with electrons increases as we go down the group. But guess what guys, on period 3 they all have the same number of shells filled with electrons, right? Sodium is, let's see, period 3 is 1, 2, 3, yeah, sodium, magnesium, aluminium. So sodium is 2.8.1, magnesium is 2.8.2, aluminium is 2.8.3. See, they all have 3 shells filled with electrons. So how do we know the trend? Guess what guys, for periods the atomic radius decreases. Okay, this is one different thing across a period. So what that basically means is that sodium's atomic radius is the highest in period 3 and argon's atomic radius is the lowest in period 3, and it decreases from sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. The atomic radius decreases. Okay guys, there's a reason for this, but to be honest with you, I never was able to understand this reason. It has something to do with nucleus attraction, but it's a bit hard to explain. I was also not too sure. So we're just going to remember that it decreases across a period. Okay guys? Alright. Now, electronegativity when we go across a period. What did we say electronegativity was? Negativity is, let's think about it. It is the ability of an element to gain an extra electron. Okay, so I'll just write this down. Ability of element to gain electron towards nucleus, because remember guys, the nucleus is the one that pulls the electron closer. So let's look at the electronegativity as we go across period 3. Okay, I'm going to write down all the elements of period 3. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. We won't talk about argon because there's no electronegativity, it is stable. So sodium's electronic configuration 2.8.1 followed by 2.8.2, 2.8.3, 2.8.4, 2.8.5, 2.8 2.8.6 and 2.8.7 for chlorine. You see how it's changing, guys? This loses 1 electron. This loses 2 electrons. This loses 3 electrons. But then we don't know so much about this one because it has 4 electrons. This gains 3 electrons. This gains 2 electrons. This gains 1 electron. Basically, what I'm trying to tell you guys is that as we move from the left to the right of a period, the electronegativity increases. Now, the reason for this is because of the decrease in the atomic size. There's always a link, guys. When we go from left to right in a period, the atomic radius decreases, therefore the electronegativity increases. Okay, guys, let me just write that down. Electronegativity, my handwriting, increases across period because atomic radius decreases. Okay, and I know this doesn't really make sense, guys, but let's just try to memorize this. Okay, a lot to memorize, but once you memorize it, it sticks with you. It's been so long since I studied this stuff, but I still remember it. So guys, it says that when you go from the left to the right in a period, the metals are on the left hand side and the non-metals are on the right hand side. Isn't that true? Sodium and magnesium are metals. Aluminium is a metal. Silicon we don't know yet. And all these, phosphorus, sulfur and chlorine and also argon, are non-metals. So that's true, right? Now, elements in period 3, they change from solid to gas when going across the period. Let's check this out. Sodium is a solid, alkali metal. Magnesium is a solid, alkali earth metal. Aluminium is a solid metal. Silicon we don't know yet. Phosphorus is, oh, sorry students, we are talking about the phase, my bad. Sodium is a solid, magnesium is a solid, aluminium is a solid. We don't know about silicon, but phosphorus is a gas, sulfur is a gas, chlorine is a gas, argon is a gas. Okay, guys? I don't know what's wrong with me. Sometimes I just don't even think before teaching. Sorry, guys. Now, what else do we need to know? Yes, one more thing I want to talk about is the definition of electropositivity. Electronegativity, we said, was the ability of the element to gain an electron due to the attraction towards the nucleus. Now, electropositivity is the opposite, okay? Electropositivity is what TVT, electropositivity, is what we see in group 1 reactivity. Electropositivity increases as we go down the group. Electropositivity is the ability of an element to release electrons. From valence electron shell. Does this make sense, guys? Yes. So, we've never talked about this particular group. There's a group in the periodic table, elements such as silicon, boron, arsenic, germanium. These are all something called semi-metals or metalloids, okay? Semi-metals, or the other name is metalloids. What this means is they possess half metal, half non-metal properties, okay? In SPM, if they ask you an example, just remember silicon, arsenic. These would be good enough, okay? Let's look at the table. Silicon, arsenic, non-metals. What are they called? Metalloids, semi-metals. Not non-metals, sorry. Then, what else? From the period, we know that sodium, magnesium, and aluminium, which are on the left-hand side, are metals. We said silicon is a semi-metal, and the thing about semi-metals is that they are also poor conductors of electricity, and phosphorus, sulfur, and chlorine are non-metals. Okay, guys? Now, one more thing I want to stress about is something called basic, acidic, and amphoteric. Okay, basic, acidic, and amphoteric oxides. Now, what I want you guys to memorize is really simple. One second, guys. Why am I finding it so hard to find this stuff? 59. All right, just give me a second, guys. Okay, now basic, acidic, and amphoteric oxides is just a name given for this oxides in period 3. So I want you guys to memorize this once again, okay? How do we form oxides? We react the elements with oxygen, okay? So, for example, I have sodium. Remember sodium from group 1 reacting with oxygen. What did we end up getting? Sodium oxide, Na2O. And then we balance this, 2 sodiums here, 2 sodiums here. Then you have 2 oxygens here, only 1 oxygen here. So you put a 2 here, but now you have 4 sodiums. So you get a 4 over here, correct? 4 sodiums, 2 oxygens, 2 oxygens. So everything on the left, sodium and magnesium, are basic. Okay, guys, these are called basic oxides. Everything on the right of the periodic table, so silicon, phosphorus, sulfur, and chlorine are called acidic. What about aluminium? Aluminium is the exception, guys. Aluminium is what we call amphoteric oxides. Okay, guys? So please remember this. I repeat, sodium and magnesium oxide are basic oxides. Silicon oxide, phosphorus oxide, sulfur oxide, and chlorine oxide are called acidic oxides, whereas aluminium oxide is amphoteric. What is the chemical formula of aluminium oxide? Aluminium is Al3 plus, oxide is O2 minus. When we cross multiply, we get Al2O3. All right, guys, this is aluminium oxide and it's amphoteric. So, what else are we going to talk about? We have covered most of this. Let me see. I'm missing transition elements, so we're going to cover transition elements. While we're doing that, we talked just now about semi-metals or metalloids. Remember, guys, examples are silicon and arsenic. If you can remember germanium as well, very good. They are poor conductors of electricity, okay? All right, so we've talked about almost everything in the periodic table, but we've never mentioned this yellow group. You know, I kept telling you guys we're going to come back to this, we're going to come back to this. Now, one element that I want to focus on is this, our good friend copper. Remember when we were doing chapter 3, guys, we were forming something called copper 2 oxide. And remember when I explained to you and said, why is there a 2 here? We'll come to it in periodic table. Well, here's the time, guys. Over here, copper 2 oxide means that our copper is Cu2 plus. There's also a copper 1 oxide. So copper 1 oxide. This is why we put the 1 or 2. It is to distinguish between Cu1 plus and Cu2 plus. Welcome to transition elements, guys. Transition elements are types of elements that are present from group 3 to group 12. Okay, they have their own specific set of properties. One of the most important properties, as you have seen, is that it exhibits or shows two different multiple charges. You can have +1 and +2 in a same element. Okay, guys, we're going to go through the properties really quick. So let's see. Yes, I'm going to read this out to you, guys. Transition elements are present from group 3 to group 12 of the periodic table. Some of the properties are as follows. Transition elements are solids, they have shiny surfaces, they are ductile, they are malleable, they have high melting and boiling point, they are good conductors of heat and electricity. But guess what, guys? You don't have to know any of this. There are only 3 things you need to know about transition elements, and that are their special properties. SPM loves to ask this question. Okay, so let's see. 3 special properties of transition elements. Okay, and you guys need to remember this. The first one was the one we saw just now. Remember copper, you have copper 1 plus and copper 2 plus. So the difference in the charges, they are called oxidation number. So what is an oxidation number? Again, don't worry about it. We'll come to that in redox reaction. So the first property of transition elements is that they exhibit or they show different oxidation numbers. Okay, guys, remember this phrase, oxidation numbers. Transition metals exhibit different oxidation numbers. They also form colored compounds. What this means is that transition elements, whenever they react with other elements and form compounds, they form colored compounds. We are not going to go into each color because we don't have time for that, guys. They may ask you a 1-point question on paper 1 for the color of a compound, but don't worry about it. Just know that it forms colored compounds. One last thing about transition elements is that they act as a catalyst. And we will see this in chapter 9, manufacturing of sulfuric acid in the industry. Okay, so remember that, guys. All you need to know for transition elements are they are from group 3 to group 12 of the periodic table. If you want to know some of the properties of them, they are all metals. So when something is a metal, it has a high melting and boiling point. They will have high densities, they will be good conductors of heat and electricity, and they are solids, okay, guys, because they are metals. 3 special properties of transition metals, as we said, like copper 1 plus and copper 2 plus, they have different oxidation numbers. They also form colored compounds. The last one, they act as catalysts. We can also talk about the, I'll just mention the properties really quick for transition elements. Actually, no, we don't even have to go through that. So that's it, guys. We are done with periodic table officially. I'm trying to get some questions. Actually, let's do a question right now, okay, guys? If you bear with me, I can find, let's see. Let's find a question from Negeri Sembilan. Since most of my students are from Negeri Sembilan, we'll do a trial question from periodic table for Negeri Sembilan. Okay, guys? And you see this. I promise you, this is going to be so easy. Okay, let's look at all the paper 1 questions, okay, guys, for periodic table. Okay, this third question. Diagram 1 shows one of the uses of group 18 elements to reduce the evaporation of metal filament. Which of the following is the element used? Now, guys, before I answer this, I'm going to teach you John's way of solving problems, okay? We're going to break the problem down and then talk about it and then answer. Which of the following is the element used? Okay, so we studied the special properties of group 18 elements. Neon is used for, let's see, we had helium, hot air balloon, right? Neon, remember we said Tokyo. Argon, we said light bulbs. This looks like a light bulb, right? Krypton was LASIK surgery, so it's not krypton, it's not helium, it's not neon, it's argon, guys. The answer is C. So you see, when we break down the question, it's so easy. So that's one periodic question, periodic table question. Let's see, nothing from periodic table, nothing from periodic table. Which shows an octet electron arrangement. Okay, let's break this down. Octet electron arrangement. That means 8 electrons in the valence shell. This has 2 electrons in the valence shell. This has how many electrons in the valence shell? 2. What about this? 1, 2, 3, 4. What about this? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the valence shell. This is an octet electron arrangement. The answer is D. So easy. Okay, none of this from chapter 4. Let's see. Okay, is this, no, this is chapter 5. Let's see. Okay, which statement is true about the atom of group 1 elements? Do we need to know this? Let's see. No, this is chapter 5 as well. So, okay, guys, which oxide turns red litmus paper to blue when dissolved in water? This question looks scary, but remember we did the experiment just now, group 1 elements reacting with water. Remember lithium plus H2O? I told you, you don't get lithium oxide, you get lithium hydroxide plus hydrogen gas. Well, this experiment applies to lithium, sodium and potassium because they are all group 1, right, guys? So, sodium oxide, that looks correct. Carbon dioxide, that's not group 1. Sulfur dioxide, not group 1. Copper 2 oxide, not group 1. So, the answer is obviously sodium oxide, guys, A. You see how we build into it? Oh, awesome question. Atoms of element X has electron arrangement of 2.8.18.18.7. So why do these elements have 18 in the third and the fourth shell? Let's not even bother about that yet. In which group and period is X located in the periodic table? So group is based on the number of valence electrons. We have 7. Does that mean the group is 7? Think, guys, remember I said that when the valence electrons are 3, 4, 5, 6, 7 or 8, you have to plus 7 to the to the valence electrons. So the group should be 17. What about the period? The period are the number of shells filled with electrons. 1, 2, 3, 4, 5. So group 17, period 5. The answer is D. Now the trick in this question, the answer A and C is obviously wrong. The trick is between B and D. They give you the same period of 5. The trick is the group 7 versus 17. Just remember, guys, the rule about 3, 4, 5, 6, 7 and 8 valence electrons, always plus 10. Okay guys, we're good to go. No periodic table, no periodic table. Periodic table. Let's see. Any more periodic table? No, no. And all, believe me guys, all these questions are, they look hard right now, they are all kachang. Let's see. No, 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 no. Okay, no, no. Not yet. I think that was all the periodic questions for this chapter, for this paper. About 5 or 6 though, quite a lot, right? What is this? Is this, I see red litmus paper. Which of the following change? No, 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 not. This is another chapter. Okay, no. Okay, paper 2 should have a periodic table question, I'm pretty sure. Oh, there you go. Alright guys, let's enjoy doing this, okay? Diagram 2.1 shows a portion of the periodic table of elements. The letters listed below are not the actual symbols of the elements. Okay, cool. So we have group 1, 2 and period 1, 2, 3, 4. Okay, cool. So by using the letters in diagram 2.1, which element exists as a monoatomic? Okay, we know this already. Monoatomic is obviously what group? Group 18, noble gases, right? So the letter is Z. The reason is because it is in group 18. The electron configuration is going to have octet electron arrangement. It is chemically unreactive, chemically inert. Now guys, this is a 2-mark question, okay? So 1 mark is going to be the letter, 1 mark is going to be the reason. So obviously I was, talking too much. So the letter is going to be Z, the reason is going to be, let's think of one reason, okay? Monoatomic because it is chemically unreactive and chemically inert. So that's the reason, guys. Element W belongs to a group that has special characteristics which differentiate it from the other group. Okay, element W, I know already which group this is in. Transition elements, right guys? So name the group transition elements and state one special characteristic of the group. We know 3 characteristics, guys. Remember, exhibits different oxidation number, that's the first one. Formed colored ions or compounds, that's the second one. The third one, acts as a catalyst. There you go. Super easy, 4 marks. Write the chemical equation when Y is dissolved in water. What is Y? Y is chlorine. Okay, so let's do this. Let's look at it again. So when Y is dissolved in water, we need to know what Y is. This is the importance of the periodic table, memorizing the first 20 elements of the periodic table. So this is placed, Y is placed in group 17. That means it will have 7 valence electrons and it's in period 3, meaning 3 shells. So its electronic configuration is 2.8.7. So what element is this? This is immediately, it's chlorine gas, right guys? But let's pretend we don't know that. We know that it's Y and Y reacts with water. So chlorine gas, or Y square, actually just give me a second guys, let me just double check this to make sure I'm doing it the right way. Okay, so chlorine gas, in this case we write it as Y square because chlorine exists as a diatomic molecule, reacts with water, which is H2O. Now we didn't practice this equation, but let's think about it guys. The positive, which is H, will react with the negative, which is Y or Cl. So what do we get? HCl, which is H plus and Cl minus, right? Cl is just Y. So we get HCl, which is Hy, because in this case we are supposed to not know what is Y. What do we have left? Okay, we used one H, we used one Y. We have a H left, we have an O left, and we have another Y. So we get H, O, Y. Do you get it guys? Let's balance this. You have two Y's here, you have two Y's on the right. Perfect. You have two H's on the left, you have two H's on the right. You have one oxygen on the left, you have one oxygen on the right. So guys, I'll just write this out for you if it was chlorine. Cl2 plus H2O. Since H is positive, Cl is negative, they react together. And when you react together, you take the ion form. H plus Cl minus, forming a compound is HCl. And what do you have left? You have one H, you have the O, and you have one Cl. So HOCl. Does that make sense guys? So easy. So we know the chemical equation when Y is dissolved in water. Okay, these are, let's see. Okay, this is ionic and covalent compound. So that's it guys. Yeah, that is periodic table for you. I can find one more example for you guys just because I want to help you guys ace this. So let's do Kelantan. Unfortunately it's in Malay, but I think because Kelantan, they love using Malay. So okay, Raja Satu. No, you know what? We're not even going to do this. I don't like to do Malay. So what we've already understood this chapter well. Just go over it again guys, and if you have any questions let me know. Okay, see you in chapter 5. Bye guys.